Once the pulverized coal hits the boiler, it's game on. The furnace reaches temperatures over 2,000 degrees Fahrenheit, turning water in the surrounding tubes into superheated steam almost instantly. This isn't ordinary steam. It's under extreme pressure, ready to unleash massive energy. The steam blasts through pipes straight to the heart of the plant. The steam turbine. Picture a giant fan the size of a house. High-pressure steam slams into thousands of precisely angled blades, forcing the turbine to spin at incredible speeds, up to 3,600 revolutions per minute, connected directly to a massive generator. This spinning motion creates electromagnetic fields that generate electricity on an industrial scale. We're talking hundreds of megawatts, enough to power entire cities. Absolutely epic engineering. Next up, how they keep this beast running without wasting a drop. Inside the boiler, temperatures soar past 2,000 degrees Fahrenheit, turning the pulverized coal into a raging inferno that heats the surrounding water tubes to their limits. Water flashes into superheated steam almost instantly, pressurized to hundreds of times atmospheric pressure. This steam is a powerhouse of energy. It rockets through massive pipes straight to the turbine hull, where it slams into blades of colossal steam turbine. Imagine a machine the size of a locomotive. Thousands of precision-engineered blades catch the steam's force, spinning the entire rotor at up to 3,600 revolutions per minute. This incredible rotation drives a giant generator attached directly to the shaft, converting mechanical energy into electrical power through electromagnetic induction. We're producing hundreds of megawatts here, enough electricity to light up entire cities. Next, we'll see how the steam gets recycled to keep the cycle going non-stop. After doing its job spinning the turbine, the steam is exhausted at lower pressure and heads to the condenser, a gigantic heat exchanger that turns it back into liquid water. Cooling water from rivers, lakes, or dedicated cooling towers flows around thousands of tubes inside the condenser, absorbing the heat and causing the steam to condense rapidly into water. This condensed water is then pumped back to the boiler to be reheated into steam again, creating a closed-loop cycle that saves massive amounts of water. Meanwhile, the cooling water heats up and is sent to towering cooling towers where it's sprayed and evaporated by huge fans, releasing heat into the air as white plumes rise high above the plant. This efficient system keeps everything running continuously without wasting resources. Incredible closed-cycle engineering. Next, we'll cover how the raw electricity gets transformed and sent to your home. The spinning turbine shaft is directly coupled to a colossal generator as the rotor turns inside a magnetic field. It induces massive electrical current in the stationary windings through electromagnetic induction. This raw electricity comes out at around 20,000 volts, but that's not high enough for long-distance transmission. Losses would be huge. So it heads straight to enormous step-up transformers in the switchyard, where voltage is boosted to hundreds of thousands of volts, sometimes over 500,000 volts, for efficient travel across the grid. Circuit breakers and switches manage the flow safely, while insulators prevent deadly arcs. From there, high-voltage transmission lines carry this power across miles on towering steel lattices to regional substations, where it's stepped down again for distribution to homes and businesses. This seamless journey from coal to your outlet powers modern life. Truly a mega engineering marvel. To meet strict environmental standards, modern coal plants are equipped with advanced pollution controls. After combustion, flue gas passes through electrostatic precipitators that use high-voltage charges to capture over 99% of fly ash particles, the fine dust that would otherwise escape the stack. Then, flue gas desulfurization scrubbers spray limestone slurry to remove sulfur dioxide, converting it into gypsum for wallboard production. Selective catalytic reduction systems cut nitrogen oxides, while activated carbon injectors capture mercury. Meanwhile, bottom ash from the boiler bottom is quenched, conveyed, and often reused in concrete or road base. Fly ash collected is pneumatically transported to silos for beneficial reuse in cement, reducing landfill needs. These systems drastically cut emissions, turning potential pollutants into valuable byproducts and protecting air and water quality. Impressive commitment to cleaner energy. Now, let's wrap up with the big picture. Safety is paramount in a facility of this scale. Multiple redundant systems, from automatic shutdowns triggered by sensors to backup power supplies, ensure nothing goes wrong. The central control room acts as the brain, with operators constantly monitoring every parameter via advanced SCADA systems. Temperature, pressure, emissions, vibration, all in real time. Alarms alert instantly to any deviation, and layers of protective gear, gas detectors, and fire suppression keep personnel safe. Regular drills and strict protocols minimize risks. From coal intake to electricity transmission, this mega power plant runs 24/7 with incredible efficiency and reliability, generating clean, stable power while meeting rigorous environmental standards. It's a testament to human engineering, turning ancient coal into modern electricity that powers our world. Modern coal-fired power plants achieve impressive thermal efficiency, often exceeding 40% in supercritical designs, where advanced boilers and turbines convert more coal energy into electricity while minimizing waste heat. Real-time monitoring systems and AI-assisted controls continuously optimize combustion, airflow, and load to maintain peak performance and reduce fuel consumption. Looking ahead, emerging technologies like carbon capture and storage are being integrated to further lower CO2 emissions, making these facilities more compatible with future energy goals. From the initial coal intake to the vast transmission network carrying power across regions, this massive plant operates as a reliable backbone of the grid, delivering steady electricity to millions of homes and industries day and night. This is a complete journey of electricity generation in a coal-fired mega power plant, a remarkable demonstration of large-scale engineering turning fuel into usable power. The plant's auxiliary systems keep everything balanced. Cooling water is continuously drawn, circulated through condensers to recover heat, and returned after cooling in towers. Exhaust gases, now clean of most pollutants, rise quietly from the stack, meeting modern environmental limits. The coal supply chain operates non-stop, feeding pulverized fuel to maintain steady combustion. The turbine generator duo delivers reliable power output, maintaining grid frequency and voltage for seamless integration. In full view, this mega coal-fired power plant combines raw fuel handling, intense heat conversion, mechanical rotation, and electrical generation into one cohesive system. It stands as a testament to large-scale engineering, turning coal-stored energy into electricity that powers modern civilization day after day. The process forms a complete chain. Pulverized coal ignites in the boiler, heating water to superheated steam under extreme pressure. This steam expands through turbine blades, converting thermal energy into mechanical rotation at high speeds. The turbine shaft drives the generator, where spinning magnets induce electricity in windings through electromagnetic induction. Output voltage is then stepped up in transformers for efficient long-distance transmission across the grid. Every component, from fuel handling to final power lines, works in precise coordination, transforming coal's chemical energy into reliable electrical energy on a massive scale. This interconnected system demonstrates how a single mega power plant sustains vast energy needs through sophisticated engineering and continuous operation. The entire system works as one. Coal is continuously prepared and burned. Steam drives turbines with precision. Generators produce electricity, and transformers send it far across the grid. Cooling loops recycle water efficiently. Pollution controls protect the environment, and monitoring ensures reliability. This coal-fired mega power plant is more than machinery. It's a synchronized masterpiece of engineering that converts ancient fuel into modern power for millions. From intake to output, every step demonstrates human ingenuity on an immense scale. This is how electricity is generated in one of the world's largest energy facilities. Thanks for watching.